welcome back to AGT STEM. Today we're going to be watching a video about ruthenium. So, without further ado, let's hop to it.
Sample of ruthenium sponge. So the ruthenium metal has been precipitated to form a very fine particles. So here, we'll just open the box.
I'm rather ashamed that I made a big mistake about the name of ruthenium. I thought it referred to somewhere in Middle Europe, perhaps in Czechoslovakia, whereas ruthenium actually comes from Ruthenia, which is the Latin translation for the country that is now called Russia. And in fact, the element ruthenium was first discovered in Russia in the city of Kazan.
Why would that be a particular cause of shame for you?
Well, because my father was born in Russia, and therefore to get something connected with Russia wrong is a bit embarrassing.
The ruthenium is a very, very reactive metal, especially when it's formed in this very fine sponge type material.
Ruthenium was actually discovered relatively early, in the middle of the 19th century. There is some discussion whether in fact the Swedish chemist Berzelius analysed something that contained ruthenium and missed it or not, but I'm not quite sure about that. But the reason why I'm interested in this is because I did my doctorate with a supervisor, and if you look at his supervisor and then that's and go back one supervisor after another, you eventually get to the Swedish chemist Berzelius, who was my great supervisor. And you find that most of the chemists now working in the world were related to just a few pioneering chemists in the 18th century.
So the ruthenium is very, very finely divided, and if I tip it, you can see in the bottom of the vial very fine powders. But again, because of the particle size, this is really dark, very black. Very nice sample of ruthenium, very useful for catalytic chemistry.
It is as a catalyst that ruthenium is particularly famous. Ruthenium itself, if you look at a lump of a metal, is a sort of silvery colour. This is a sample of ruthenium as a catalyst. Now, because it's an expensive metal, the ruthenium is just distributed as a very thin layer on silica. Silica is like sand. And you can see that this finely divided ruthenium looks black. They're very finely divided, so it has a large surface area, so the molecules can come in and react it. And my students were using this catalyst to react an organic compound, that's one with carbon and hydrogen, and to get it to react with more hydrogen. And so they lent me this catalyst so I could show it to you. There are other ruthenium catalysts which dissolve in the solution that you're trying to get the reaction to go. And there's a very famous catalyst named after the American chemist Bob Grubbs, who won the Nobel Prize about 4 years ago. And his catalyst does a reaction which most people, even some chemists, have not heard of, which is called metathesis, in which double bonds between two carbon atoms are broken and joined together in a different way. And you can use this for all sorts of things. You can make plastics out of oils. You can make new sorts of wax. You can make a really great sort of wax that has oxygen atoms in it. And if you use this for candles, then the oxygen atoms make fragrance molecules dissolve much better than in ordinary wax. So you can have a Christmas candle which, when you light it, smells of Christmas pudding or smells of alcohol or vinegar or vanilla or whatever spice you want. And you can't do that with an ordinary catalyst, or ordinary wax. But this ruthenium catalyst opens out all sorts of things. So that's why he got the Nobel Prize. The other reason why...
He got the Nobel Prize because he made nice-smelling candles?
No, he got the Nobel Prize because he invented the catalyst that opened up all sorts of reactions that otherwise couldn't be done. Bob Grubb's compound has ruthenium, and his is the most widely used, and it's now used in a whole series of industrial processes. This is another compound of ruthenium, which you can see it's rather a nice red colour, and it has the rather unromantic name of ruthenium bippy 3 times, or chemists who use it call it Ru-bippy. And the point about this compound is that it absorbs light well and is very stable. You can shine light on it, very intense light, for a long time, and the compound doesn't decompose, it doesn't change. But what it can do when you shine light is that you can move electrons around inside the compound, and this compound, and ones like it, are being used by people to try and capture the light from the sun, capture solar energy.
So ruthenium can be used as a catalyst and for solar energy, which is pretty cool. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!